Have you ever wondered why some objects in space seem to behave in a way that defies our understanding of physics? Welcome to the mysterious world of physics, where the ordinary often takes an extraordinary twist. In the vast expanse of the cosmos, strange phenomena occur that have left even the brightest minds scratching their heads. From the enigmatic dark matter that makes up much of our universe to the puzzling behavior of quantum particles, the universe is a treasure trove of mysteries waiting to be unraveled. Now imagine a tennis racket spinning in space. You'd expect it to spin smoothly around its axis, right? But what if it suddenly flipped, spinning in a way you didn't anticipate? This isn't a trick question, nor is it a scene from a science fiction movie. It's a real phenomenon observed in space, one that has puzzled scientists for years. This bizarre behavior is not just limited to rackets. It can be observed in almost any object that is free to move in 3 dimensions, from satellites to asteroids. But why does this happen? What unseen forces are at play that cause these objects to defy our intuitive understanding of physics? These questions have led scientists on a quest to understand the principles that govern the universe. They've peered into the depths of space, delved into the subatomic world, and explored the boundaries of theoretical physics in search of answers. One such phenomenon that has been a topic of intrigue is the Bana-Dzhanibekov Effect. Named after the Soviet astronaut who first observed it, the Bana-Dzhanibekov Effect describes the unexpected rotation of objects in space. It's a phenomenon that's as mysterious as it is fascinating, and it's been the subject of intense scientific study for the better part of a decade. The Bana-Dzhanibekov Effect is a perfect example of how the universe can surprise us, challenging our understanding and forcing us to rethink what we know about the world around us. So, are you ready to delve deeper into this fascinating topic? Let's plunge into the enigmatic world of the Bana-Dzhanibekov Effect and unravel the mysteries that it holds. What if I told you that an object in space can rotate in a way that seems impossible on Earth? Welcome to the world of the Bana-Dzhanibekov Effect, a phenomenon that challenges our conventional understanding of physics. This effect was discovered by a Soviet astronaut Vladimir Bana-Dzhanibekov in 1985 during a space mission. During the mission, Dzhanibekov noticed something peculiar while manipulating a wingnut in zero gravity. It was rotating in a way that defied his understanding of physics. As it turns out, the wingnut was demonstrating a unique property of rotational motion in a zero-gravity environment, now known as the Bana-Dzhanibekov Effect. Let's delve a bit deeper into what this effect is all about. You see, when an object is free to rotate in space, it has 3 principal axes of rotation. The first 2 axes are stable, but the third one is not. This means that if an object is rotating about this third axis, it will eventually flip over and start rotating about one of the other 2 axes. This is precisely what Dzhanibekov observed with the wingnut. Now you might be wondering why this doesn't happen on Earth. Well, the answer lies in the concept of angular momentum, which is a measure of the amount and direction of rotation. On Earth, the presence of gravity and friction usually keeps objects rotating about a single axis. However, in the absence of these forces in space, objects can freely rotate about all 3 axes, leading to the unexpected flips observed in the Bana-Dzhanibekov effect. To put it simply, the Bana-Dzhanibekov effect is a demonstration of how the laws of physics can manifest in surprising ways when we remove the constraints of our everyday environment. It's a reminder that the universe is full of mysteries waiting to be discovered and understood. So the Bana-Dzhanibekov effect demonstrates a peculiar property of rotational motion in zero-gravity environments. It's a testament to the endless wonders of the cosmos and the thrill of scientific discovery. But what causes this odd behavior? Let's explore the science behind it. At the heart of the Bana-Dzhanibekov effect lie 3 fundamental principles of physics: torque, inertia, and the conservation of angular momentum. Let's break each one of them down. Firstly, we have torque. In layman's terms, torque is a measure of how much a force acting on an object causes that object to rotate. Think of it as the twisting force that causes rotation. When an object is in space, free of friction and gravity, any force applied to it will cause it to rotate. This rotation is what we observe in the Bana-Dzhanibekov effect. Next we have inertia. Inertia is the resistance of any physical object to any change in its state of motion. This includes changes to the object's speed, direction, or state of rest. In other words, an object in motion tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by an external force. In the case of the Bana-Dzhanibekov effect, the object's inertia keeps it rotating once it starts. Lastly, and perhaps the most crucial principle, is the conservation of angular momentum. This law states that the total amount of angular momentum in a closed system remains constant unless acted upon by an external torque. Think of it as the universe's way of keeping a balance sheet. If an object starts spinning in space, it will continue to spin at that same speed and in the same direction until some external force changes it. This is why, in the Bana-Dzhanibekov effect, the object continues to rotate and flip in a predictable manner. But how do these principles combine to create the Bana-Dzhanibekov effect? When an object with 3 different moments of inertia is set to rotate in space, it will stabilize around the axis with the greatest and smallest moments. However, it will not stabilize around the axis with the intermediate moment of inertia. Instead, it will exhibit a tumbling motion. This is the Bana-Dzhanibekov effect. The effect was named after the Soviet astronaut Vladimir Dzhanibekov, who observed this phenomenon in 1985 while adjusting the rotation of a wing nut in space. He noticed that the wing nut would flip over every 30 seconds, despite no forces being applied to it. The Bana-Dzhanibekov effect isn't just a cool party trick for astronauts, it's a demonstration of some of the fundamental laws of physics at work. It shows us that the principles we observe here on Earth also apply in the seemingly strange and alien environment of space. Hence, the laws of physics, when applied in a zero-gravity environment, can lead to some truly mind-boggling phenomena. Now that we understand what the Bana-Dzhanibekov effect is, you might be wondering what's its significance. The Bana-Dzhanibekov effect is not just a fascinating spectacle. It has profound implications for space exploration and physics research. In the realm of space exploration, understanding this effect is crucial for the development and manipulation of spacecraft. This understanding aids in the designing of spacecraft that can withstand the unpredictable forces in space. For instance, it can help in creating spacecraft that can stabilize themselves without the use of external thrusters or fuel, thus making space exploration more efficient and sustainable. In the field of physics, the Bana-Dzhanibekov effect serves as a compelling demonstration of angular momentum and the conservation of energy. It provides a tangible way to visualize and understand these abstract concepts. This makes it an invaluable teaching tool in classrooms around the world, helping students grasp the fundamental principles of physics. Furthermore, the Bana-Dzhanibekov effect is a vivid reminder of the strange and counterintuitive nature of our universe. It challenges our everyday experiences and perceptions, pushing us to rethink our understanding of how objects move and behave. This sense of wonder and curiosity is at the heart of all scientific exploration and discovery. In research, the Bana-Dzhanibekov effect could potentially open doors to new theories and discoveries. By studying this effect, scientists might uncover hidden aspects of physics that could revolutionize our understanding of the universe. It's a stepping stone, a piece of the puzzle, that could lead us to a broader and deeper understanding of the world around us and beyond. Indeed, the Bana-Dzhanibekov effect is more than just a fascinating quirk of physics. It's a testament to the wonders of the universe and our ceaseless endeavor to understand it. So there you have it, the Bana-Dzhanibekov effect, a marvel of physics that continues to surprise us. We've journeyed through its discovery, understanding its science, and even delved into its impact on our world. This phenomenon, named after the Soviet cosmonaut Vladimir Dzhanibekov, is a fascinating example of how the universe can still surprise us, defying our everyday understanding of how things should behave. Remember the spinning tennis racket flipping its axis in space, an anomaly that puzzled scientists for years? That's the Bana-Dzhanibekov effect in action. It's a phenomenon that highlights the beauty of physics, showing us that even common everyday objects can behave in unexpected ways under the right conditions. The Bana-Dzhanibekov effect serves as a reminder that there are always new frontiers to explore in our universe. Until next time, keep questioning, keep exploring, and keep being amazed by the wonders of science.